Uh, Welcome to our Technical Mathematics Grade 12s. Today we are going to be looking at calculus. This is the topic for today's lesson. And then we are going to be looking at a gradient and then also the cubic function under calculus. That is the subtopic that we are going to be looking at this one. And this topic, remember, it form part of paper 1, and it contribute a lot of marks for that paper. And then we should also go and visit the examination guideline for technical mathematics and just look into that document, the things that we have to understand before we go and write our final examination for technical mathematics. Is very important. Just make sure that you do have that document, and then also please just go and retrieve all the previous question paper for technical mathematics. It's very important to revise with them, because remember, this is a new baby, technical mathematics, because it was first we had exam in 2018. So that's where we first the learners wrote this technical mathematics. So we don't have much about that. So if we can just get all the previous question papers, and then even from different provinces, I think it will help a lot to prepare yourself for this coming final examination. And then you can just get into calculus and see. Now, under content, already remember I've indicated that this is part of paper 1 topic, which is contributing 50 plus or minus 3 marks for paper 1. You can see it's a lot of marks out of 150. So it's very, very important to make sure that we practice everything before we go and write the final examination for this topic. And then, but today's, we are going to be only focusing on what? Determine the gradient, average gradient, and then as well as the cubic function. Then we are going to be explaining more under cubic functions. That is the two concepts that we are going to be focusing on. And then let's see. The first, it says the steps to sketch a cubic function, because now, remember, for technical mathematics, unlike mathematics, we mainly having what? A question where we have to plot a cubic function, right? So it's very, very important to know on how do we plot or sketch a cubic function. So we need to make sure that we learn on how do we plot that. So these are the steps that you should follow when you are, or when you have to plot a cubic function. All right, the first, you have to be able to determine the x and y intercept, and then by letting y equals to 0 if we are looking for x intercept, by letting x to be 0 if we are looking for y intercept. Now remember, as for y intercept, is going to be very easy. You just put 0 where you see x, then whatever the number that you are going to be left with, that is going to be your y intercept. But now, when we go and look for the x-intercept, the total and different story there. And then sometimes you'll have to do what? Use different method to factorize that polynomial. So remember, some we have done a synthetic method to factorize polynomial. Some they have done a long division method, and then the other one they have done a inspection method. So make sure that you pick a method which you feel comfortable to work with, so that you don't make any mistake during final examination if a question comes to say calculate the x-intercept. So every time you have to make sure that you master the method that you are going to be using to calculate or to determine the x-intercept. Number two, you must be able to determine the x values of the stationary points by letting f prime of x equals to 0. Now this one, remember, for you to be able to determine the stationary points, you have to do the derivative of a given function first, and thereafter you then equate it to 0 so that you can be able to solve the x values. Y values of the stationary points by substituting the x values of the stationary point into f of x. Now, this one, just after you have determined the x values for stationary point, you take those x values, you substitute to original equation to get the y corresponding values. Number four, determine the shape of the graph when it's given f of x equals to ax cubed plus bx squared plus cx plus d. Now, how will you know the shape of the graph? Now we can see that we are having the first one that says if a is greater 0, meaning this a, if the coefficient of x cubed is positive, then how is going to be the shape of the graph? This is going to be the shape of the graph of a cubic. So it's very, very important to remember the shape of the graph just after plotting the points. Then because you are familiar with the shape of the graph, then it's going to be easy for you to plot the graph of a cubic. But now if you don't understand that, it's going to be very, very difficult to join all those points after you have determined the x-intercept, the y-intercept, the stationary points, and then you plot them. Then the fact that you don't know the shape of the cubic function, then it's going to be very complicated for you to draw the cubic function. But now, just remember when a is greater 0, meaning if coefficient of x cubed is positive, therefore this is going to be the shape of the cubic. And then when a is less than 0, and then this is going to be the shape of the graph. The shape of the graph. Remember, when you are, this one is going to be the turning point, the first turning point, and another turning point as well. So every time when you're looking for stationary points, remember stationary points is the same as turning points. Then you will always have two turning points there. You have the x values of a turning point, two x values of a turning point. Then you will then look for the y corresponding values. So this is the shape for when a is less than 0, when a is negative. If the value of the coefficient of x cubed is negative, then this is going to be the shape of the cubic function. Now let's get into the sketching of a cubic function. The first question says, given f of x equals to x cubed minus 4x squared plus 4x, determine the x-intercept. And then let's see on how do we determine the x-intercept. You let y equals to 0. You can see y is equals to 0 in this one, so that we can be able to factorize this cubic. Now, this one, there is no need for us to apply the method we have learned on how to factorize a cubic. You can see that we have a common factor there, which is x. and then we just have to take the common factor as x there, and thereafter, after taking out a common factor as x, then you can see inside the bracket we are having a quadratic. Then we have to factorize that to quadratic. And now this is the quadratic that we have factorized, which is x minus 2 and also x minus 2. And there was something that I also want to alluded on this one. Now we can see that x minus 2 repeat twice. Now every time when you come across such situation where you are looking for the x-intercepts and then two of those x-intercepts, they are the same. For instance, this one we can see is x minus 2 and x minus 2. Then that thing, it tells you that one of the turning point is going to act as x-intercept as well. One of the x-intercept or one of the turning point is going to be part of the x-intercept, right? And then also you will see when we go and look for the stationary point for this equation, we are going to get the x value there equals to 2, right? So you must always remember that if two values of a x-intercept are the same, it tells you that one of the turning point is going to be on the x-axis. And then we have x equals to 0 and x equals to 2. And then let's look for y-intercept. Y-intercept, we let x to be 0. Where you see x, we just substitute with 0. Then the answer goes to 0. That is y-intercept. And then let's proceed. Let's proceed. We're still having the same question. We just have to have new question. Now we have to determine the stationary points of this. Let's see on how do we determine the stationary point. We first have to derive, and then the derivative is 3x squared minus 8x plus 4. Then equate it to 0. It's very important, equate to 0 there. After equate to 0, you can see that we're having a quadratic. Now we have to factorize that. Then is 3x minus 2, x minus 2. And the values are x equals to 2 over 3 or x equals to 2. Remember, I have said that one of the x values of a stationary point is going to be exactly the same with one of the x-intercept, which is equals to 2 there. And then now let's look for y corresponding values. You first substitute with 2 over 3 to the original before you can derive the original equation. Then the first value is 32 over 27. Then we substitute 2, then the value is equals to 0 there. Then the stationary point is 2 over 3 is to 32 over 27. And then 2 is to 0. Those are the stationary points. And now the same question, we now have to sketch the graph of f showing all the stationary points and intercepts. Then let's see, this is going to be the graph. This is going to be the graph. Remember, I also explained the issue around the coefficient of x cubed is positive. Then this is going to be the shape. So then if you remember the shape, then it's going to be easy for you to just join these points 1, 2, and 3. Those points. So it's very, very important to remember that. So you can see that one of the turning point is now part of the x-intercept, or it is on this line of axis, which is to 0, that point there, or the stationary point. So that is the solution for the sketching of the graph. Given that f of x equals to minus what, x into x minus 3, x minus 3. You can see this one, it already factorized for us. There is no need for us to factorize it when we look for the x-intercept. Now, the first question said we should now calculate the coordinates of the x-intercept. Now, let's check on how do we determine the x-intercept on this one. You let y to be 0 there, and then this is going to be 0. Then straight, you just solve for x, because now it's already factorized for you. There's no need to factorize it. So the first x, which is this one of x minus x, is equals to 0. And this one is x equals to 3. Remember what I said about this one. If we have the two values of x which are going to be the same, then it tells you one of the turning point is going to be on what? On the line of x axis. It's going to be on x-axis. And therefore, these are the solution for the x-intercept. Then we move to this one of y-intercept. We have to write the y-intercept. And then where you see x, then you just substitute with 0 there. Then the answer is going to give us what? 0. That is y-intercept. The third question says show that f of s equals to a negative x cubed plus 6x squared minus 9x. And then you just write this. Then thereafter, the second step, you're going to multiply these two brackets, and it's going to give us what? X squared minus 6x plus 9. With x, this negative x outside, then we're going to open our bracket with that negative x outside. Then it's going to give us negative x cubed plus 6x plus 9x. So this is the same as this one. You can see that. And then determine the coordinates of the turning point or the stationary point. And then you take the original and then you derived it. Then after deriving it, it's going to give us negative 3 x squared plus 12x minus 9. Equate it to 0 so that we can be able to solve what? To solve x. But now we have just simplified it. We have noticed that 3 into 3, it goes once, and then into 12 is 4, and then 9 is 3. So you are going to divide with negative 3, and you can see everything has changed the sign. Then we can now factorize it, and the factors are x in minus 3 and x in minus 1. And then these are x values of the stationary points. You can remember what I said about this one. Look at here, x equals to 3 and x equals to 3. That is the situation that you'll come across. But when you are solving the x-intercept and then there are two values there which are the same, you must know that that is going to be the very x-intercept that you're going to get when you are looking for the stationary points. And the last question we have to sketch. Actually, we have to look for the y corresponding values for the stationary point. When we substitute 3 to original, it gives us 0 there. When you substitute 1 to original equation before deriving, it gives us negative 4. sketching of the graph. This is the solution for the graph. You can see this is the solution for the graph, because we can see the coefficient of x cubed, it was negative. So remember I said that this is going to be the shape if the value of a is less than 0, is going to be the shape. Hence we are having this shape here. You can see that. So that is the solution for the sketching of the graph. Now let's proceed. G of x equals to into x plus 1 close bracket into x squared minus 1. Determine the x-intercept. Let's see on how do we determine the x-intercept. You let y to be 0. Now the second step, you can see that we are having this bracket of x plus 1. You can see it's there. And then now the second bracket is x squared minus 1. So this is a difference of 2 squares. Then you're going to have x minus 1 and x plus 1, because the difference of 2 squares. And then you solve for the values of what? Of the values of x, which is x equals to 1 and x equals to positive 1. You can see this and this one and the same. What does it mean to you? It tells you that one of the turning point of a cubic is going to be on the line x-axis, and it's going to act as what? As x-intercept as well. Now, number 2, we have to calculate the coordinates of a turning point of G. Let's see on how do we calculate that. You first have to open the bracket and multiply and add the like terms, but you can see that there are not like terms here. You can now start deriving. After derivative, then you're going to obtain 3x squared minus 1 plus 2x. Then equate it to 0 so that you can be able to solve. We can factorize this quadratic, and then these are the factors, which is 3x minus 1 into x plus 1. Then when you solve for x, the x is going to be equals to 1 over 3, or x equals to negative 1. But because we are looking for the coordinates of a stationary point, we are looking for y values. We first take this 1 over 3 to original equation. Then it's going to give us y as negative 32 over 27, and y equals to 0 there. So the coordinate is 1 over 3 is to negative 32 over 27, and the other one is going to be negative 1 is to 0. Now we have to sketch the graph. This is going to be the graph. You can see one of the turning point is on this x-axis, and then it's also acting as x-intercept. So that's going to be the shape of the graph. So that's how we should now determine the graph of a cubic. The graph of the function g defined by the equation g of x equals to x cubed minus x is drawn below. You can see this graph is here. In this case, you are now having the graph already. It is been drawn for us. Then we'll see what are we going to be answering on this one. The first question says we should determine the coordinates of points A and B. Let's look for point A. You can see this point A and point B. Those are what? Those are x-intercepts. Those are x-intercepts. So remember, when you are looking for the x-intercept, you always let y equals to 0. So I think under solution, that is going to be a way forward of letting y equals to 0. X-intercept let y equals to 0. You just put 0 there. And the second step, you are going to take a common factor as x. And after doing that, you can see inside the bracket we are having one different of two squares. And then you just factorize that, then it's going to give us x minus 1, x plus 1. Then remember, we're still having x outside. So when you have to solve the values, it's x equals to 0 first, x equals to 1, and x equals to -1. So those are three x-intercepts. But now the question, it was very clear to us that we should determine the coordinates of A and B. Now, the coordinate of A is -1 is to 0 there. That is the first one. The coordinate of B is 1 is to 0. So we have answered the question. And the second question says coordinates of K and M. Let's look for K. K is the turning point. M is also a turning point. Then remember, we are going to apply the same procedure on how do we determine the values of x for stationary points or turning points, values of y. So we are going to apply the same thing. So you take the equation, the original one, then you do the derivative, which is going to be 3x squared minus 1. Then equate it to 0 there. You're going to equate to 0 so that you can be able to solve the value of x. Then you transpose that 1 to the left hand side. Then this is what you're going to be having, 3x squared minus 1. Now, because we are solving for x, then we are going to divide both sides with positive 3. Then you're going to have x squared minus 1/3. Then you put square root both sides. Then you're going to obtain plus or minus 1 over square root of 3. And then remember, I say plus or minus, so I try to separate the two. This is going to be the positive one, and this is going to be the negative one. So we can look the coordinate for K there is surely going to be this one of negative, because x is negative in this quadrant. So it's going to be -1 is to square root of what? Square root of 3. It's going to be square root of 3. -1 over square root of 3. Of course, this one of m is 1 over square root of 3. The positive one. Now we have to look for the y corresponding values. The first one, when you substitute with positive 1 over 3, square root of 3, it gives us -0.38. When you substitute with negative 1 over square root of 3, it gives us positive 0.38. So that is that. But now the question was very clear to us to say calculate the coordinates. So you must write k is to positive what is k equals to -1 over square root of 3 is to 0.38, and or the coordinates of m is 1 over square root of 3 minus 0.838. So that is going to be the answer. And then the last question, I think we're going to be answering it to the next slides. Determine the values of x for which g prime of x is less or equals to 0. And now we have to do this one, and then what is the solution for that? And then you say x is greater or equals to -1 over 3 square root of x, and the x is less than or equals to 1 of square root of 3. Let me just try to explain this one so that if it happens that you get similar question during exam, then you are now going to be able to solve it. Now, when we do you can see it's a f prime, I mean g prime. So that is the derivative of a cubic function. Now, and then it's going to give us what? It's going to give us a quadratic. Then we are going to obtain what? A quadratic. Now, but because now we want where x, where this g prime of x is less than or equals to 0, it must be below the x-axis. Now, I just want to explain something for you, my dear learners, that you should know that the we need to look into what we need to look into. Let me just try to draw that. This is a parabola graph. That's going to be the parabola graph. So this graph of G, after it becomes the parabola, because now remember I said to you that the derivative of a cubic is giving us a parabola graph. So this parabola graph is less than or equals to x axis, because negative there is negative, 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 negative. So now we are looking for the x-intercept there of this point, the x-intercept there. Now for you to be able to get the x-intercept, now remember the x values of the stationary point. Those are the x-intercept of a parabola graph. Let me repeat myself. I'm saying the x-intercept, the x values of the stationary points are the x-intercept of a parabola graph. Meaning this point here is going to be negative 1 over square root of 3, and this one is going to be positive 1 over square root of 3. Then the graph is it less than 0 on this portion here. Let me just do it. This portion that I'm trying to mark it is where the graph is less than or equals to 0. So it's from this point, is from this point here, and also this point there. So it's from this, let me show, to this. So you can see the arrows are facing each other. So we cannot go to the left, we cannot go to the right, because when you go to the right, that's where g of prime is going to be greater 0. But we want where g prime of x is less than or equals to 0. So it's between these 2 points, which is negative 1 over square root of 3, positive 1 over square root of 3. Then now you can see this is going to be the solution. We're going to use n between. That's why we had to write this solution in this manner, which x is greater or equals to this number, because from here, if we go to the right, those values are going to be greater or equals to negative 1 over square root of 3. And then it says x is less than or equals to 1 over positive 1 over square root of 3. So when you move from this point, you go to this. We also know that those values are less than 1 over square root of 3. So that is the solution for that. Average gradient. Now remember this one of average gradient. We have dealt with gradient when we were doing grade 10, grade 11. And then when we had to calculate the gradient, we are supposed to have 2 points for us to be able to calculate the gradient. All right. And then now this one of average gradient was introduced to us in grade 12, where now we are having equation. You can see there's an equation there. And then we have what? The 2 x values. Then now, how are we going to calculate the average gradient? It's not that difficult. It's the same as the one that we did in grade 10 and grade 11. Now, the only difference on this one is that we don't have a point, but now we are having a 2x values and equation. Then now, under solution, how are we going to do that? We first have to look for the y corresponding values so that we can have 2 points, and then we are going to be using the same formula to calculate the gradient. Now let's look into that. First, we're going to take the first x value there, which is negative 1. You substitute to the given equation so that you can get the y corresponding value. In this case, you can see the first is negative 3. then we are having a point. You can call it that point A, which is -1 is to -3. Then we are looking for another point. We're going to take this positive 3, you substitute to the given equation. Then you're going to get y corresponding value as +5. Thereafter, you are having a point. You can call it point B, which is 3:5. All right. And therefore, since we're having 2 points, we can now calculate the gradient. You write the formula for the gradient. You substitute that the average gradient that we are looking for is equals to 2. So that's how easy it is. It's so easy to calculate that. And then let's look another question under average gradient. Determine the average gradient between the point x equals to 1 and x equals to 4. You then substitute the value of 1 first to the given equation, then the y corresponding value equals to -5. That is the first point. And then you take the second x value there, which is +4, to the given equation. Substitute, then the answer is going to be -8 as y value there. The second point is 4 is to -8. Now we can now write the equation when you calculate the gradient, and then you substitute, then the value that we are looking for, the average gradient, is now -1. It's -1. Now find the point of a contact. Find the point of a contact where the two graph meets. Now it says the gradient of a tangent is equals to the gradient of a graph at the point of contact. Thus, the derivative of the graph of the point of contact is equals to the gradient of a tangent. Now, this is the equation that we are using when we calculate the equation of a straight line or the equation of a tangent. So then it says gradient is equals to the derivative of a curve or a graph. We should always remember that gradient of a tangent or gradient of a straight line is equals to the derivative of that curve or a graph. Always the case. Now let's see how are we going to work on that one. And the first question says the gradient of the tangent of this curve is what? Is 6, right? That is the gradient. Determine the value of what? A, which is this point. Let's see on the solution, how do we determine that? First, we said the gradient of a gradient of a tangent, which is 6 in this case, is equals to the derivative of a curve of a graph. You can see we are given equation there, the graph here. Then when you do the derivative of this, then it's going to be equals to this 6. Then I think you're going to do the derivative, which is -4x. Then we equate it to 6, I mean, because we said it's equals to the gradient of a tangent. Therefore, we can now solve the value of x, which is -6/4. Simplify it, is going to give us -3/2. But because we know this represents the value of x there, then a is therefore a equals to -3/2. So that's how you should now determine that value of x, or the value of a to that point. We have another question that say find the point of contact. Determine the point of where the gradient of a tangent is -4, and now we're giving a curve like this one. Let's see. First, we take the equation that we're given. The derivative of that is now 2x plus 2. Then equate it to the gradient of a tangent. And we're looking for what? The x value there. Then you just transpose the divide with 2, then the x value is -3. Meaning from that point that we are looking for the values, then the first value, that the value of x is now -3. Then to get y corresponding value, what are we going to do? We are going to substitute the x value that we have just determined to the original equation before we derived. We substitute it, which is -3 there. and the answer is going to be positive what? The answer is going to be positive. It's going to be positive 2. So the point that we're looking for is negative 3:2. So that's how you should now determine what the point of a contact. Then for remember on this concept we also have to learn on how do we determine the equation of a tangent. But now we did not have that question where we had to calculate or determine the equation of a tangent. We only dealt with determining a point. Remember, to get the equation of a tangent, we need a point and a gradient. Now we were learning on how do we determine a point first, because already we are having a gradient, we have a point. If a question comes to you and say determine the equation of a tangent, it's going to be easy for you because already we are having a gradient, also a point. So we have learned on how do we determine what? A point. All right, thank you very much. This is the end of our lesson for today. I hope you are going to be joining this lesson again, our lesson again for tomorrow, same time, same place. And then this is going to be your message for today's lesson, my dear learners, that says the study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you will probably be late, all right, or be too late. So I thank you very much. Have a nice evening. Bye.